Mm, okay. Let's make the chat available. Okay, I can't think of any real announcements other than as long as we're keeping up with our work in Pearson and doing the best we can with Alex, you should be fine. So this is week 11. We're approaching the middle of week 11. I think we have about. I just know that we're going to be done. Like we're going to have taken the final by the time Thanksgiving hits. Like when we go into the Thanksgiving holiday, we're going to already be done with the class. So that's right at about a month away. Like it's gonna be quick. Let me let whoever. Let's see who that is. Okay, let's hop over here. Come on. Yeah. So the main thing is just make sure to get Pearson in as much of order as soon as possible. Get it in order as soon as possible. Um, before and also the closer we get to the final, the more unreliable Pearson is going to become. I think what happens is that the servers get overrun because campuses nationwide, the finals are approximately the same, so you have all these people on the server all at the same time, and it typically slows down and becomes unreliable. So you definitely want to just go ahead and get caught up, try to get ahead if possible. Let's see. Okay, he's going to be here. Awesome sauce. All right, looks good. All right. So yeah, other than that, no major announcements. We're just gonna go on with the next section. So this is section today. We're going to be continuing section 2.3, uh, polynomial long division, synthetic division, and the rational zero test. After 2.3, I think we have section maybe 3. I think we only have 2 sections after this, and then the rest is like preparing for the final, taking final exams, getting our final documents in order to close out the semester. Hopefully, you guys were able to use this. I know this is a little bit unorthodox. Hopefully, I mean, everybody has their own unique Morehouse experience or college experience, especially HBCU experience. Um, it, it it is nice to kind of be on campus and experience like actually living on campus. That was like it was some of the most tumultuous, but it was honestly some of the best years of my life. I mean, I had a lot of fun. I made sure to have my fun. Like in any way it goes, I'm going to make sure to have my fun. And it's a very unique experience. Hopefully, that's my request is that you all can like safely get that experience to live on campus, being in the dorms, and just it really helps to kind of like figure yourself out and kind of come into your own being, right? But it's really hard to figure yourself out being at home or you know anything of that nature. Okay, but yeah, so all right, so let's kind of pick up where we left off from last time. And we'll be done. We only have a few slides left, so we'll probably finish out this section today. And then for like, we'll use whatever time we have today to kind of as a homework session. And then when we come back on Thursday, I'll probably just go through the homework for this section on Pearson. Your homework will be the same, just with different numbers. And if you want me to go through your question specifically, you have to click on the Ask My Instructor tool, and it'll send me a screenshot, and I can work on yours specifically with your numbers and everything. But if I do it myself, the numbers are gonna be different, and you're gonna have to like figure it out yourself. I mean, it's not totally yourself. You're just gonna have to adjust with your numbers. Let's see. Who is this? Oh, he was already in here. Okay, yeah, that's right. That's good. All right. So yeah. Anyway, and then probably on Friday we'll probably still just do our best to try to take some time to practice some more factoring. Um, we'll see what we can do. All right. So in this example, it says that we have the combined petroleum consumption C in quads by a group of the most economically developed countries in the world from 96 to 2011 can be modeled by this function, right? There is a typo. I think an X is supposed to be here, right? There's supposed to be an X there. Where X equals 0 represents 1996. X equals 1 is 97, so on and so on. Let me see something. Cool beans. Also, if you are able to vote, please go ahead and do some early voting. You might want to go ahead and do it. Just get it done and over with. It's very important. Okay. So the model indicates that C of 5 equals 238 quads. So if we plug in 5, we get 238 quads of petroleum were consumed in 2001. Find another year between 2001 and 2011 where we consume 238 quads of petroleum. Okay. So all we're going to do is set this equal to 238 and solve, right? And they gave us, we know that when x is 5, we get 238. So let's take advantage of that. Let's use that, applying some of the things that we've talked about, and see how it unfolds. So first, let's go back to paper. Let's get some graph paper going. Okay. So we have this consumption function. Consumption function. What's your function? Okay. We got 021 x cubed minus 0.973. That doesn't look like a 3. Come on. 3 x squared plus 11.347x plus 202.965, right? So what we want to do is set that equal to 238. We're going to set it equal to 238. I kind of ran out of space, so I'm going to get this all on one line. Okay. I'm going to move this over here and expand it back. Okay. Like this. All right. So then if we set it as 0, we can use c equals 5 to solve, right? Because if we plug in 5, it's going to equal 238. So let's go ahead and set it to 0. All right, so then we get this 0.021x cubed minus 0.973x squared plus 11.347x. Hey Siri, what's 202.965 minus 238?
202.965 minus 238 is negative 35.035.
Okay, let's see what we got here. All right. All right. All right, let's see what else we got. Okay. Okay. All right. So now we know that 5 is going to be a solution of this equation. That's what we were given, right? If we subtracted 238 when we plug in 5 in this one, we're going to get 0. So we can confirm that with synthetic division, right? So if we do synthetic division where 5 goes into the chair and our exponents are accounted for, it goes 3, 2, 1, 0. So we're in the clear there. Let's take these coefficients. We got 0.021, negative 0.973, 11,347, and it's negative 35,035. We do synthetic division with these numbers. Remember, the first one just comes down, 0.021. Hey Siri, what's 5 times 0.021?
5 times 0.021 is 0.105.
Hey Siri, what's that answer minus 0.973?
0.105 minus 0.973 is negative 0.868.
Hey Siri, what's that answer times 5?
Negative 0.868 times 5 is negative 4.34.
Hey Siri, what's that answer plus 11.347?
Negative 4.34 plus 11.347 is 7.007.
Okay, and we get our. So we confirmed that 5 is a 0. Now, we started with the degree 3 polynomial, and so at this stage, we have this depressed equation. So now it's going to be degree 2, right? So this is going to be this squared times that plus that, right? So let's write out what we have. So right now, if we took the original polynomial and we write it in a factor form, we have x minus 5 times this thing, 0.021x squared minus 0.868x plus 7.007 equals 0 in this case, right? So now we want to factor that one. I'm just going to use the quadratic formula. To me, that's the simplest one. Because now that we got it down to a quadratic, we can use a quadratic formula. So quadratic formula goes x equals, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. All right? So then if we plug in the corresponding components, I think I might need some more space than that. Then we get 0.868 plus or minus the square root 0.868 squared minus 4. Our A is 0.021. Our C is 7.007 divided by 2 times our A. Okay. So I'm just going to use the calculator for this. Let me pull up my trusty dusty rusty. This guy right here. That's clear. Okay. All right. So first I'm going to start with the numerator. I have 0.868. I'm going to do the minus the square root. We got 0.868 squared minus 4 times 0.021 times 7.007. Let's see, this closes off the square root. This closes off the top. I'm going to say divided by the bottom is 2 times 0.021. And this closes off the bottom. We should get an answer. Okay, that looks good. So then that was the minus. Let's go back and do the plus, right? Because remember the plus or minus. So right here, I'm going to change the minus to a plus, and we get 30.3 bar, right? But then the question asks us to find another year between 2001 and 2011. Let me see, 0 was 96. So that's 5, from 5 to what? Is that 15? So notice that 11 is between 5 and 15. So when x is 11, I think the year is 2007. Right? So in the year 2007 was another year where it hit the 238 quads of petroleum consumed. Okay. Let me check this first. Let's see. Let's go like this to view, single page. Let me see. Since c equals 5, therefore x equals 5 is a 0 of our polynomial, right? So then we did synthetic division, right? So with the factor form, the depressed equation, I think they got the same thing that we got. And then we used a quadratic formula. They got the same 2 results, but we wanted something between, what was that? 2001 and 2011, I think it was. All right. And so the year we got was 2007, right? Okay, let me see. I know there's somebody in the waiting room. And again, I am monitoring the chat if you have questions. Come on. Let's go. Somebody's munching in the background. Here it is. Okay. All right. We are moving and grooving. Okay. So next we want to take a look at the rational zero test, right? I think we mentioned this before, but let's just revisit it. So given a polynomial with integer coefficients, where the leading coefficient is not 0 and the constant term is also not 0, then we have this P over Q is going to be a rational number. Oh, this was another class that I did this with. I was like, who did I recently do this with? This is another class. So we can do P over Q is going to be a rational number in lowest terms. There's going to be a 0 of the function. So P is going to be the factor of the constant term. Q is going to be the factor of the leading coefficient. And then, so if our polynomial has a rational 0, it's going to be somewhere in the list that we generate, right? So let's see this rational zero test in action. We're asked to find all the rational zeros of this, and first we're asked to list the possible rational zeros, right? So it's asking us to do our p over q, where the p comes from the constant term, so we want all the factors of 3 over all the factors of 2, right? So in this case, again, it's going to be the factors of 3 are plus or minus 1 and plus or minus 3. The factors of 2 are plus or minus 1 and plus or minus 2. So if we do all the combinations, let's do everything on top divided by 1, we get plus or minus 1, plus or minus 3. Now everything on top divided by 2 gives us plus or minus a half and plus or minus 3 halves, right? So what we're saying is that if this polynomial has zeros, it's going to be, if this polynomial has rational zeros, it's going to be somewhere in this list. That's the rational zero test, right? So then we just want to start testing our zeros, right? We could target some bounds, but yeah. Let's just go like this. So let's start testing these zeros. So I'm just going to start with 1 and do rational zero test. Notice the exponents go 3, 2, 1, 0, so we're in the clear there. Then if we do synthetic division, we get 2, 5, negative 4, and negative 3. If we do synthetic division, remember this guy comes down. So we get this. This is this, 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 and we found a 0. We got lucky. Because it can be kind of a pain. Hey, thanks. Thank you. I know you're trying to warm up the vocal cords. I get it. Come on, you want to help us? You going to help us? All right. So, help us out. What do we do next? Right? So, fortunately, we found a 0. So, now, since we found a 0, we started with the degree 3. At this stage, we have a depressed equation, right? So, we can write it in terms of squares. So, 2x squared plus 7x plus 3, right? So, at this stage, let me see. If 1 is a 0, that means x minus 1 is the factor times 2x squared plus 7x plus 3. Now we want to factor this. And we're setting it equal to 0 because we want to find the zeros, right? We could use the simplest way. Let me see. Two numbers that multiply to give us 6. Let me show you. Two numbers that multiply to give us 6 and add to give us 7 are 1 and 6, right? I'm trying to think of the simplest way. I'm probably going to do factor by grouping. So to do factor by grouping, there's several techniques that work here. She is like in her zone. She's like, oh, I'm good now. I'm not. I get to like have contact. She's like, I'm good. But she's just chilling. It's so funny. All right. So we said 1 and 6. They multiply to give us 6 and they add to give us 7. So I'm intentionally going to put. Actually, I was going to put the 6 next to the 2, but it doesn't really matter. So let me see. I'm going to say plus 1x plus 6x. So I broke that 7 up into those two numbers that we found. All right? Okay. So now when I go to do factor by grouping, if I group the first two together, they have a common factor. We can factor out what? It looks like an x. We're going to be left with 2x plus 1. So the hint is we're looking for another 2x plus 1 on the other side. So I'm just going to go ahead and write it because I know that's what I'm looking for, right? So what can we factor out of the second two? It looks like we could factor out a 3 from both of those. All right, and this x minus 1 just comes down, equals 0. All right, I think 3 times 2 is 6, 3 times 1 is 3, all right? So now they have a common binomial factor. I'm almost out of space, so I'm going to do a few maneuvers here. So then ultimately we get the following. X minus 1. We can factor out the common binomial factor. We get 2x plus 1. And we're left with x plus 3. Okay, equals 0. And then if we set each one equal to 0 and solve, let me get this out what you're doing. If we set each one at 0 and solve, x equals, we get 1, negative 1/2, and negative 3, right? Make a decision. Thank you. All right, and so let me kind of reorganize this just to put it in a more amicable order or presentation. And we're going to check these results to see if they work. Again, I am monitoring the chat, or feel free to unmute yourself if you have questions. Let me just reorganize this really quickly. Here it goes. Get warming up the vocal cords. All right, we need this to go this way, like this looks good, and this needs to go about here, kind of like that. Let me do one other thing. Take all of this, move it over. I'm gonna move this here. How's it jumping? So irritating. And then you can go there. Okay.
Hey, Professor.
Go ahead.
Can I be excused? I'm at practice right now.
No. Just
Is that what?
no. You can't do that. Now, as long as you're silent, I'm not gonna know what you're doing, but officially I'm gonna say no. Right? Okay? Because you're not supposed to be at practice during class time. Just sit tight, just hang tight. We're just working, just kind of chill. Do what you feel like you need to do, but the official answer is no. But, you can kind of do whatever you need to do, really. Okay, let's check these results. So, come on. I didn't really want to show that. I don't know how that's switched over. Anyway. All right. So we want to check these in the original, right? So I'm going to go to my y equals, and I'm going to type it in. 2x to the power of 3 plus 5x squared minus 4x minus 3. Okay. I'm going to quit, and I just want to call on that. I'm going to go to variables. I'm going to go to the right to y variables, number 1 and number 1. So now when x is 1, we should get 0. Okay. When x is a negative 1/2, we should get 0. And when x is negative 3, we should get 0. Okay. All right. So this looks good. All right. So let's keep it moving. And yeah, let's keep going. So yeah, we took the factors of the constant term, which was the negative 3, plus the time. We go from when the 350, I think it's 505, right? Yeah. So the factors of the constant term right here. The factors of the leading coefficient are here. And then, so we say P over Q, so it's the negative 3 over the 2. And then I think they essentially did the same thing that we did. All right. We got lucky, we found the first 0. And then I think we got these results, okay? So, if you have questions like from the homework, now is a good time to ask it. Otherwise, I'm going to hop over to let's get some practice without factoring, because I know we need practice there, and we haven't really been doing it. I just want to think about how I want to access it. Yeah, because I don't like to show all this. All right, so let's do this. Let's hop over here. Let's switch this to just the waiting room for right now. Let's go here. Actually, I have it here. This one. We can go here. This one. This one. Okay, so let me show this. What I'm doing. Okay, so if you go to our Blackboard page, and I think at the very last option when you first log in is going to be folder number 7. It's called Box. When you click on that link, it should bring you to something similar to this, right? So then here, if you go to handouts, this is where I have the entire chapter on factoring. Let's start here with this overview on how to approach a factoring problem, right? So we have this on how to approach a factoring problem. Let me can I just share this? Share? No, that's not. Okay, that's okay. Okay, let me see. Can I write on this? Okay, give me a moment. Let's do like this and like this, and I think we're good. I want to do this. Notability. And yes, I want to add it to this one. Import. Okay. Oh, you're acting up? Okay, that's fine. Okay, we can hop back here. It's this one. Okay. Okay. So we have this slide on how to approach a factoring problem, right? So whenever we have to factor, this is like honestly for college algebra, these are pretty much all the scenarios. Wait a minute. It says the only assignment we have to do is Alex and the test. I'm not sure what you mean by that. It's still our regular assignments. If you finish all those assignments in Pearson, then what you're saying is correct. But and I think the exam will open up. Like exam 3 is scheduled to open next Wednesday, and it'll be available until that Saturday. And then I think we'll have like maybe 2 more sections remaining, and then we'll be ready for the final. So we're gonna start trying to recap as many of these sections as possible. Start preparing for the final. The final will pretty much be the same rhythm as these other exams, all online. That's kind of the long and short of it. The assignments are basically everything that you see in Pearson, and then Alex. Alex counts as like 10% of our grade. Pearson is 90%. Okay. Yeah. Okay. So hopefully that answered that question. Let's move you here. Come on. Okay. So with factoring in this course, so the first question we ask ourselves whenever we have to factor is there a greatest common factor, right? So this is where we always start. Is there a GCF, right? And we're gonna take some practice. We're gonna work through some practice examples. Is there a greatest common factor? It's the first question we ask ourselves. So then once we factor out the greatest common factor, then we typically have one of mostly 3 scenarios. There might be a few others outside of this, but it's generally one of the next 3. Then we ask ourselves, how many terms are we trying to factor? Are we trying to factor 2 terms? Are we trying to factor 3 terms? Like we just did at least one of them where we had 3 terms. Whenever we have 3 terms, especially if it's a quadratic, I pretty much use the AC method of factoring. I kind of do the same thing every time whenever we have 3 terms. And it works most of the time, like 90% of the time, if not more. And then we ask ourselves if we have 4 terms, right? So then terms are things that we add and subtract. Factors are things that we multiply or divide, right? So we ask ourselves, how many things are we adding and subtracting? Is it 2, is it 3, or is it 4? So if we have 2 terms, then it's usually one of these 3 cases. Either difference of squares, difference of cubes, or a sum of cubes, right? So these are the 3 cases when we have 2 terms in general, when we have 2 terms. When we have 3, I typically just do the AC method. Like you actually just saw me do it. Sometimes you'll see me do it using the box method, but it's the same thing, just a different presentation style. And we're going to get some practice with these momentarily. And it's a whole chapter devoted to this. Like it's plenty of practice here. And then if we have 4 more terms, you actually just saw me do this one as well. I took my trinomial, I broke that middle 8x into one, what was it? Sorry, yeah, I broke that 8 into, I think it was like a negative 1 and a positive 9, something like that. And so then we had 4 terms at that point. Then I did factor by grouping, right? I did factor by grouping. So let's kind of go through the chapter and see this stuff in action. Or at least start making our way through it. And this is just to try to help, get some practice because I know we need to talk about this. So let's hop back over to box and get rid of that. Let's go here. So now, not now. So again, we have an entire chapter devoted to factoring. So I'm going to open up this chapter. This is an old chapter that I scanned from when I first started teaching college students in 2009. So we have this entire chapter. I don't want to move it, but yeah. We have the entire chapter devoted to factoring, right? So if we look, this is chapter 6 from this text. This is like an intermediate algebra text from Florida Institute of Technology. But we see these 5 sections. The first one is greatest common factor. Remember, that was the first thing we talked about. We said whenever we have to factor, that's going to be the first thing we ask ourselves. GCF. Also in that section, we're going to explore factor by grouping. Then in section 6.2, we have factoring trinomials. Then 6.3, special factoring. And then 6.4, a general approach to factoring. And 6.5 is solving equations by factoring. Right? So again, factoring I know is one of those topics that gives students a hard time. So I was like, okay, well, let me go ahead and get a copy because I know students can use this going forward. So let's just kind of work some examples. Let me see if there's anything pertinent here. So I think we have the solutions over to the left. Classroom example. Okay. So let's take this, right? Let me see the time. Heck, I wish I could do polls. Polls would be nice here. Okay, just take a few minutes. And okay, for instance, if we're looking at A, what's the greatest common factor? What do they have in common? All right. If we're looking at A, they both have 7, right? Let's look at that 32 and that 24. Let me get a copy of this. I'm trying to avoid the answers right now. And let's just do this classroom example. So this is kind of exploring greatest common factor. Okay. I'm going to take that. Come on. I'm going to drop it right here. You are not behaving properly. Let's go like this. Okay, let's just drop it here for now. Boom. Okay, and then let's add a page. Oh, okay, you're doing that thing. Go like this, like this. Nope. Go back. This one. Okay, that's fine. Let's add a page. Let's change the view to seamless. And okay, and we're going to add this one. Add. All right. So now let's work this, right? Okay. This isn't too bad. Again, this is just the start, and this is an introduction. So then for part A, I'm doing that thing again. We got 7k plus 28, right? What do they have in common? We can factor out a 7 from both terms. We're going to be left with k plus 4, right? So then that's that one. That's that one factored. So then B, we have 32m plus 24, right? So now we want to find the greatest common factor. So let's do this. Let's list out the factors of these numbers, right? So 32 is going to be what? 16 times 2. So 2 to the power of 5. 2 times 2 times 2 times 2 times 2. That's 32, right? 24 is what? 6 times 4. So then 24, 2 times 2, 2 times 3. And let me line it up the following way. Let me line it up like this, right? So then this is one technique. If we want to find the greatest common factor, the GCF, and do your best. It can be a little bit confusing the greatest common factor with the least common multiple, right? That takes a little bit of effort on your part to distinguish between greatest common factor and least common multiple. Okay, so the greatest common factor here, we want whatever factors they have in common, whatever whatever is common to both, right? So they both at least. Let me kind of do like this. And let's go style fill like this, right? They both at least have 1, 2. Let me copy, paste. They have a second 2, and they both have 3 2s, right? So then the greatest common factor is going to be 2 times 2 times 2, which is 8. Okay, and let's not box that. So then that means we can factor out an 8 from both of these, and we're going to have 8. Now, if we factor out 8 from what, 32, we're left with 4m, and the second one we're left with, oh, wait a minute. Yeah, the 3, right? Hopefully that was okay. So we listed out the factors of 32. We listed out the factors of 24. 32 and 24, the greatest common factor was 8. Okay, let's try another one. So then C, we have 8a minus 9. Let me see the time. We have 8a minus 9. 8a minus 9. What do they have in common? 8 is 2 times 2 times 2. 9 is 3 times 3. So that's it. There's no, they don't have anything in common. And then D, 5z plus 5. What do they have in common? They both have 5. If we factor out 5, z is left in the first one, and 1 is left in the second one. Okay? So let's just let's hop back to box and just check our answers. Okay. So here's a classroom example, and the answers are right there. So the first one, 7k plus 4, 8 times 4m plus 3. There is no common factor other than 1, so we just left it, right? And then 5 times z plus 1. Okay, that was pretty good. All right, so let's do another one. And again, you have access to this. You have access. I'm just trying to block that answer. Okay, so let's do it like this. Let's get a screenshot. I'm right here. We can go like this. That's fine. And we're gonna drop that log right here. Okay. All right. So let's give this one a go. And again, you can access all of this stuff that you see me using. It's in our box folder, right? So again, we're asked to factor out the greatest common factor. And so I'll probably be making my way through this chapter as with whatever downtime we have. Other than, I do want to take at least one day to go through our homework. And like, again, if you have a question about homework, you can ask it now. Now is a good time to ask questions about homework and things of that nature. Otherwise, I'm just going to fill the time with this factoring chapter, and there's more. I hope I got the next one too, because the next one is pretty good too. Okay, so let's do part A first. So then we have 100m to the 5th minus 50m to the 4th plus 25m to the 3rd, right? So what's the least number of m's that they all have? They all have at least m to the what? 3, right? What's the greatest common factor from 100, 50, and 25? Okay, let's do the same method that we just did. You might be able to see the answer, but let me just do what we just did so you get some practice. Now, 100 is what times what? 100 is 10 times 10. So that's going to be 2 times 2 times 5 times 5. Okay? 50 is what? 2 times 25. So I'm going to say 2 times 5 times 5. And then 25 is going to be 5 times 5. So when we go to find the greatest common factor, we want one of each factor that they have in common. So they all have at least one 5 and a second 5. So then the greatest common factor is going to be 5 times 5, which is 25. You may have seen that off the rip, but I just wanted to kind of do the same technique again just to confirm that it works. So then we get 25. Now, from the 100, if we remove the 25, we're left with 4. So that's going to be 4m squared. From the 50, if we remove 25, we're going to be left with 2. So that's going to be minus 2m. And then the last, is it 1 plus 1? Are there two numbers that multiply to give us 4 and add to give us negative 2? No, right? Factor out the greatest common factor, so I think we're done there. Okay, let's do part B. So then part B, we have 5m to the 4 x to the third plus 15 m to the 5 x to the 6 minus 20 m to the 4 x to the 6, right? So if we're going to do the GCF, okay, let's just, here we can kind of keep that. Let's start with the coefficients, right? So we have 5, we have 15, we have negative 20. Is what, 4 times 5? So that's going to be 2 times 2 times 5. 15 is what, 3 times 5. Okay. And then 5 is just 5, right? So then it should be clear that the greatest common factor in this case is 5. As far as the coefficients are concerned. Okay. So then when we look at the variables, we want to take the variable with the smallest exponent, right? Let me see. Like for instance, if we look at the m, this has 4 m's, this has 5 m's, this has 4 m's. So they all at least have 4 m's. So we're going to say m to the power of 4. If we look at the x's, this one has 3, this one has 6, this has 6. So they all have at least 3 x's, so x to the third. Okay, that's the greatest common factor. So then we can factor out 5m to the 4 times x to the third from each one. So that first term becomes 1. The next one becomes 3m x to the 3. The last one becomes a negative 4 x to the 3. Negative 4. Yeah, we're just going to stop here. Okay. All right. So let's check our work. It's here. Come on. So then part A, 25m to the third forms squared minus 2m plus 1, okay. 5m to the 4x cubed, 1 plus 3m x cubed minus 4x cubed, okay. Okay, so this looks good. All right. So this one is an example on common binomial factor. that one usually kind of trips students up as well. We actually, again, we did this one like not too long ago, a few minutes ago. I called it common binomial factor, and you'll see it here in just a moment. Right here. Okay. So let's do this common binomial factor. Okay. So then part A, let's try this. We're given what? A plus 2 times A minus 3 plus A plus 2 times A plus 6. So again, terms are things that we add and subtract, right? So we have two main terms. Factors are things that we multiply. So from these two terms, what do they have in common? There's something that both of these things have. And we're going to highlight it in blue. They both have this A plus 2, right? So that's called the common binomial factor. We can actually factor that out. So it's almost, it's like we reverse distribute it, right? So if we factor out the A plus 2, if we factor out A plus 2, it looks like we're left with A minus 3 plus A plus 6, right? Let's see. We can combine like terms here. That's going to give us 2A plus 3. And that should be the result there. Okay. Let's try another one. So then B, we have y minus 1, y plus 3, minus y minus 1, y plus 4. Is there a common binomial factor? I think they both have this y minus 1, this guy in blue. Okay? So then we can factor out that common binomial factor. Again, it's like we reverse distribute. Right? So they kind of merge. So it becomes y minus 1. We're left with y plus 3. Now, I'm going to distribute that negative. It becomes negative y minus 4. Okay. So then we can combine like terms. We get y minus 1. Let me see, y minus y, so these add to 0. 3 minus 4 is negative 1. So then we can do something like 1 minus y. And that should be the result here. Okay, let's do this C really quickly. Let's just go like this. So then C, we have k squared times a plus 5b plus m squared times a plus 5b squared. Okay. We still do have a common binomial factor. They both have this a. Let's try this again. A plus 5, and there's another a plus 5 here. Okay. So we're gonna do again. We're gonna factor out that a plus 5b, which is like reverse distributing. Uh-oh. Okay, so if we factor out the common binomial factor, we get this a plus 5b times what's left over is k squared plus m squared, right? And we can't factor any further. So if we're factoring, we know that we're done when as long as we finish with something times something else. Like if as long as it's all multiplication and division, then we're okay. Notice we got the blue thing times the black thing. Let me see. So we got these results. Okay, let's compare that over here with the results here. So the first one, a plus 2 times 2a plus 3. The second one, we got 1 minus y, which is the same as negative y plus 1. That's okay. And then the third one, a plus 5b. Uh-oh. Oh, shoot. I totally missed something. Let's go back. So, this one we need to fix. Right here. So, when we factored, that's okay. But remember, we had a squared there. I saw it, as someone said, be sure to catch that square, and I just totally missed it. So, because we had two of those blue things, one of them persists, right? Because we only factored out one of them. So, the other one persists, right? So then, if we want the final result, we get this. And then we have the k squared remains. If we distribute this m squared, so this guy distributes, and let's do like this. Ooh. So if we distribute the m squared, is that what they did? We get m squared a plus 5m squared b, right? So they either stopped at the line that we stopped at, or they stopped at the line above, but they mean the same thing. I'm gonna go with this one. Now let's check that one. Ooh. Okay, I think we got it this time. Yeah, I saw that and it slipped on that. A plus 5b, we got k squared, m squared a, 5m squared b. Okay. So, let me see, if we go to 15, I want to go, okay. Let's do another one. Okay, I think we did those. So let's do this one. In 2 ways. Oh, we see the answer there now. Let's just do it. That's what we're here to do. Okay. And let me rewrite it since it's so blurry. This says to factor, we got negative 6r squared plus 5r in 2 ways, okay? What do they have in common? I think they both have r, so we could factor out just the r by itself. We're going to be left with negative 6r plus 5, or we could factor out negative r. I'm going to put or. If we factor out negative r, that's going to give us 6r squared minus 5. So again, we could always multiply back to confirm that these at least work. Oh, and we don't need the squared. I think this one is good there. Minus r, 6r minus 5, r times a negative 6r plus 5. Okay. Okay, yeah, let's do this one. So this one looks like an example on factor by grouping. We use factor by grouping whenever we have 4 or more terms, right? So if we feel like we need to factor and we have 4 or more terms, then again, we use factor by grouping. You see here. Okay. Let's hang out for a little over 5 minutes. Okay. Then we can go. I always forget. I think it's. I always forget. I'm not sure if it's 5:05 or 5:15. Let me check. Yeah, let me check. Hang on. What time do we get out again, guys? I always forget with you guys. I think it's 5:15. No, for you guys, I think it's actually 5:05. Yeah. You're okay. Yeah, so we need to stop in like about 5 minutes. Okay. All right, so let's get a copy of the original. We have this 6p minus 6q plus rp minus rq. So now, you don't always have to group it the first two. You just have to try different grouping arrangements and see if you can factor anything, and see if you can get a common binomial factor or some kind of common factor. So I'm going to start by just looking at the first two. Now, I see off the bat that the first two we can factor out as 6 from both terms. All right, so if we factor out 6, we're left with p minus q. All right, so I'm anticipating another p minus q over here. Now let's see, can we factor, is there something we can factor out? It looks like we can factor out an r from both of those. And indeed, we're going to be left with p minus q. So now we have this common binomial factor. So this is going to be equal to, we got p minus q times 6 plus r. We know it's a completely factor because we're multiplying our results. I think that's okay for right now. Okay, guys, if there aren't any burning questions, what's today? Tuesday? I'll see everybody on Thursday. Thanks for being a great audience. I'll see you on Thursday. Take care. All right, let me go ahead and share this again. Send it to box. This one, notes. Dang, did I skip over week 10? What happened in week 10? How come there's no notes there? I don't understand how it's missing. Anyway.